Hi, welcome to Praveen Tutorials for Physics. As you know, this is a Praveen. In this video, I'm going to discuss with you about a human and colorful world topic that is here, power of lens. In this video topic, you are going to learn what is power of lens, what is the relation between the power of lens and focal length, what are the units of power of lens, how to find the power of lens, and also how do we identify the type of a lens using its power of lens. So these are the topics we are going to discuss in this video. So in the human and colorful world, we have a topic that is power of lens, which is denoted by the letter P. What is power of lens? Here, the power of lens is defined as the degree of a convergence or divergence of a light rays can be achieved by a lens called power of lens, or reciprocal of focal length is also called as power of a lens. So in any way, we can define this power of a lens here. So here, look at the first definition is given as the degree of convergence or divergence. Here, as we learned in the fourth lesson, when we use convex lens or the concave lens, they can converge the light rays or diverge the light rays. So here, how it will be achieved. So here, look at this convex lens I'm drawing on the screen here. Here, what happens if the parallel beam of light ray incident on a double convex lens? Here, after refraction, they are going to be converged at a common point. Here, the light ray which is passing through the optic center of the lens, it goes straight without any deviation. Then the remaining rays are going to be converged at a common point. That common point here we can call it as focus. So here simply that you can converge before this or after this also. It will be designed by the lens maker here. So this point may be inside or outside. That will be depend on the lens maker while it is designed. So here what happens if we use double concave lens here? So same parallel beam of light rays I'm going to incident on the double concave lens. After the refraction, they are going to be diverged. So here that red color ray I'm showing differently because it is along the principal axis or passing through the optic center of the lens. It goes straight without any deviation after refraction. Then the remaining light rays are going to be diverged. Then by drawing the backward rays, we'll get a common point on the principal axis that we can call as point of divergence. So this is called the degree of divergence of light rays. So it is also designed by the lens maker while it is making, right? So this is actually the first sentence meaning. Then we'll go for the second one, right? What is that? Here, what is the relation between the power of lens and focal length? So for this, I am depending on the second definition. Reciprocal of focal length is called as power of lens. So here, power of lens is denoted by the letter P. That reciprocal we will write as 1 by F. But the condition is here, F is measured in meters. So this is the relation between the power of lens and the focal length. Or this is also given in centimeters, that the focal length of lens is 100 by F measured in centimeters. So anything we can use for the power of lens and focal length relation. Then we'll go for the next one. Here, what are the units of power of lens? Actually, according to this formula, we can say per meter or per centimeter, but we are not going to use that one. Especially that units are given for the power of lens is dioptres. So power of lens measured in dioptres, it is denoted by the letter capital D here. Here, by knowing the power of lens, you are able to identify the type of lens also. That I will give you a sentence here. How it is, I will explain you at the end of this video also. Here, power of lens is negative for a concave lens. Power of lens is positive for a convex lens. Then, how to calculate the power of lens or the focal length of the lens? So I will explain you both here. Let us look at that. Here, as example, I'm taking one of the problem here. Doctor advised to use 2D lens. What is its focal length? So here power of lens is given. What is its focal length? When we know the power of lens, you are able to find out the focal length by using the formula here. P equal to 1 by F, may be measured in meters, or it may be measured in centimeters, will be written as 100 by F in centimeters. So using this relation, we are able to find out its focal length. So here power of lens P is equal to given as 2D. So note down that. Then here using the formula F is equal to 100 by P, because I'm considering the focal length in centimeters. So measured in centimeters is equal to 100 by P. Let us substitute the value of P here. That is equals to 100 by P value is given as 2. So 2 diopters substituted as 2. Then let us cancel here by using the 2 table. 1 is 2 and 2, 50 times is 100. That remains as 50 by 1. That is equal to what? 50. It is measured in centimeters. So the focal length we will get in centimeters. Therefore, F is equals to 50 centimeters. So I got the focal length by knowing the power of lens. So let us tabulate the values by taking the focal length here. How to find power of lens? So I will take the first column as focal length in centimeters, and next one I will take it as here power of lens in diopters. Let us assume the focal length of the lens is 100 centimeters. Here, the focal length is considered as 100 centimeters. Then I'm going to use the relation here, power of lens P is equals to 100 by F in centimeters. That 100 centimeters, I'm going to substitute in the relation, that is equals to 100 by F is 100. So 100 by 100 gets cancelled. Then it remains as 1. So that 1, I will take it as power of lens. Let us drop that value in the table. As lens power is 1 diopter. Then I'm assuming the focal length as 50 centimeters here now. So what is the power of lens if the focal length is 50 centimeters? So same formula, I'm going to use 100 by F in centimeters. Let us drop the 50 centimeters in the relation. That is equals to 100 by 50. Then cancel it. 50 one time and 50 two times. So I got power of lens as 2. Let us drop that value in the table. Then if you take 25 centimeters as the focal length here, 100 by 25, that will give you 4. So without calculation also, we are able to say that. If the focal length is assumed as 20 centimeters, then the power of lens will be 100 by 20. That will be given as 5 centimeters. So like this, we are going to find out the focal length or the power of lens by knowing at least one of the quantity, either power of lens or the focal length. Right? So this is the concept of this video. I think it is clear to you in understanding the concept. So thank you. I'll meet you with the next video.